Hi everyone and welcome back again. I'm going to go through with you now polyamides. Now there's lots of different types of polyamide. I'm going to look at kind of some fictional versions of these to help you get to grips with what a polyamide structure actually is. And we're going to look at versions that have one monomer to make the repeating unit and also versions that have two. And we may mention the peptide bond work as well, but that's not really on the new spec, and so I'll probably just direct you to another video towards the end for that and just give you a snippet of information. But it's always good to keep watching more videos, and I think people forget that. So what we've got to begin with is we've got our diamine just here. So I've left off the H's on my Molymod kit just here, otherwise it gets a bit much, but I've drawn the skeletal for you. So we've got 1,2-diaminoethane. And also to make my polyamide, I've got a dicarboxylic acid here, and this is propane 1,3-dioic acid. And you can see I've made that from the kit nice and clearly here. I've got my NH2 group on this structure, and I've also got my carboxylic acid structure just here. Now, you need one molecule of each of these to start looking at the repeating unit, but remember in your equation for these, you would have N of each of them, and then you're adding them together. So you'd have an equal number of each to ideally make your polyamide. So what actually happens then? Remember, we're looking at condensation polymerization. So it's the removal of a small molecule of water to create a bond, which can result in our polymer. Now, for this then, and obviously for the full definition of that, you really have to reference your own specific exam board. For instance, with OCR, it's okay to say that two molecules reacting together to form a large molecule or polymer with the elimination of a small molecule such as H2O or HCl. But that varies from exam board to exam board, and really, remember, your definitions are going to be a tiny proportion of your exam. It's better to understand the chemistry that's taking place. So what's happening here? Well, I've got N of that and N of that. They're ready to go. And I'm going to eliminate a small molecule of water to create my polyamide. Now, how do I do that? Well, I need to look at the two functional groups here and eliminate some water to create a bond. So physically, what I need to do is I take an H from here, pull that, and I'm going to take the OH here off that, nice and simple. And this molecule of water then, that I've just taken from there, is kicked out. So that we're going to just put over here. And these two now, I'm going to clip them together, and what I've formed here is an amide functional group. So I'll just spin that over so it's in one line, and I've got my amide functional group in the middle just here. Now this isn't quite a polymer just yet. This wouldn't be good enough as a repeating unit. I am going to keep going with this in a moment. But first off, let's just have a little quick draw of what we've got, because that will help us understand what we can see at least in the middle. So I'm going to do this over two lines just to make the most of the space. So I've here got my nitrogen, which is bonded to this carbon just here, which is still double bonded to an oxygen. And that nitrogen we can see there, don't worry about drawing it up or down, is still bonded to an H. Then the nitrogen has got two carbons, and I'm going to draw this out in more displayed now. I know I use skeletal at the top, but you can mix and match most of the time in the exam unless they give you a specific instruction, and I do want to make this nice and clear for the video. So for this then, on this side, I've got this nitrogen group here that I'm going to come back to very shortly, but I'm going to leave it like that for now. And on the other side here, for the carbon, I've got a little CH2. Remember, I've not shown all the H's on the Molymod kit. And then at the moment, I've got my carbon just here, and I'm going to show the double bond O, but I'm not going to do much else with that because I need to come back to it in just a moment. So at the moment, this is kind of one molecule that's been formed from those two reacting together. And I did say I wanted to look at a polyamide. So what I need to do next is I need to take out another molecule of water using both sides in the same way that I created this in the middle. So it looks like an amide functional group is present, half at either end. So what I need to do now is I take off another H, just like that, from this end. And I'm also going to take off the OH from that end, and I've got to now my repeating unit, how my repeating unit is meant to look. And I've also got my H2O, which I've just absolutely butchered, and I've got my H2O over here like that. So, looking at my structure now at either end, what I need to show is my carbon now has no bond just here. So we show kind of an arm just reaching out to the side, and I've got my brackets around that. And on this side, I've still got my H. Could have put that on earlier, but didn't. And you can see I've got no bond here anymore, but I do need to show my arm reaching out that way. And the idea is quite simple. What I could do is, for my repeating unit, I should be able to close up the molecule and create the amide functional group again. So that should balance nicely. There are different ways of showing either end just here, but I like this way because I think it's a nice even split of the functional groups. I also need to make sure to put my H's in here. I very nearly forgot. That wouldn't have been very good at all. And then on the outside of these brackets here, I'm just going to put a little N. Now you'll notice here I've got 2 molecules of water, but obviously the number of water molecules you're going to get is going to be dependent on the value of N in these equations. So the way that we represent that for these is by putting, in brackets just here, 2N minus 1 H2O. By putting that on the outside of the brackets just here, we're able to relate the N and the number of waters to how many N's we had in the equations. And this is it's very specific to OCR A-level chemistry, but this is the OCR-friendly way of doing so. And we can see here now what we've got is our repeating unit, which is the simplest portion of our molecule repeating over and over. Now, well, simplest portion of our polymer repeating over and over, I should say, because obviously a polymer and a molecule are different things. So, what we can see here is this is the minimal amount that is repeating over and over again inside our polymer chain, and we can see our functional groups either end and our link in the middle. Now, because we can see the link in the middle, so because we can see, and I'll just circle it up, this is our amide link in the middle, that tells me that I have actually formed this polyamide from 2 different monomers. If I didn't have this link in the middle, but I maintained these kind of functional group presences on either end, then that would suggest to me that I'd made this polyamide from just 1 monomer, which had both functional groups to begin with. Let's have a look at how that would look in terms of a molecule sense now. Okay, so we've obviously got something that looks a little bit different now, and what we can see is we've got something that resembles an amino acid, and we've got our NH2 just here, and we've got our carboxylic acid group on this end. So before we had monomers that had both of the same functional group, and they formed a polyamide. Well, I can still form a polyamide from this, although because it's this amino acid, we would look at calling this a polypeptide, or we would look at long-term at making this a protein. Now, you don't need to know those terms for OCR A-level chemistry, but you do need to be able to interpret the fact that an amino acid could form a sequence of one amino acid after another in the same way that we can actually do this with polyesters, which is in a different video that you can get to via the cards of this video. So, looking at this polyamide then, what I can do with this next, I've got this structure, which if I draw it out, and again, I'll draw this out in skeletal just here. You can see we've got the NH2 down here at this end. I've got 1, 2, these 2 carbons just here, and then coming down on this side, I'll show the functional group in more detail, just to make it nice and clear. We can see we've got this carboxylic acid feature just there. So I can even spin that round, and it's exactly the same layout just there. So I've got that molecule, which is now exactly like that. That's nice and clear for you. So what I would do is I would have N of that, and then just lots of this would end up forming a long chain. And so over on this side then, if I just move that to the middle, what I can show for this is I take out my molecule of water just like I did before. So I'm going to take off the NH, there it goes, and I'm going to take off from this side the H2O just there. So I'm left with this kind of shell in the middle. And what I've just taken away is my molecule of water. So that's over here. Now for this then, on this side, I now show my repeating unit, which is this just here. So I've got my square brackets going to my N, which is the blue. It's still got the bond to the H, which we can see just there. And then if I just show up, I've got my chain down the middle of 2 carbons. Whoops. And that gets me then to my C double bond O just here. There we go. And I can put the H's in for this. I know they're not in the Molymod kit. I let myself down a bit there by not showing them, I think. And I close off on that side because this carbon then doesn't have that bond clearly going on. But it would be connected to the next nitrogen up, for example. So this would be repeated and stamped over here. And then over on this far right-hand side, what I now show is just N-1 H2O. And what we can clearly see now is I've got this as my repeating unit, going over and over and over. And because there's no visible amide link in the middle of this, just here, that's a way of spotting that this polymer here, this came from 1 amino acid. So this polyamide was produced from 1 amino acid-like structure, just here. So it was one monomer as opposed to the example we saw up here, which was two monomers being put together. They could give you different amino acids to make an alternating pattern for this, and you'll find this in a lot of the F324 legacy past papers, and you can find them from our VLE, or you can get them from your teachers. They can get them from the OCR website. Now, the final thing I want to mention is, if I don't have an diamine reacting with a dicarboxylic acid, is there anything else that I can do here? Because even down here, we've got the kind of amino and acid groups. Is there anything else that can happen? Well, there is. There's one more thing. Okay, so here's what else can happen. Now, this looks incredibly familiar, and it is. We've got our NH2 just here, and our NH2, just close it up, on this side. So we've got our 1,2-diaminoethane once again. But then on this side over here, we've got something that looks a little bit different. What's different about this is I'm going to have my skeletal formula with a little bit of display chucked in for clarity. C-double bond O, that's obvious, just here. So we can see those two C-double bond O's. There they are, holding them. And then these here represent the fact I can have chlorines, making this a diacyl chloride. Now, these two, just like the dicarboxylic acid and the diamine, can actually react together. We use N of each of them. And what happens is, very similar thing, we do eliminate a small molecule. It's just this time the small molecule is slightly different. So, I'm going to take off the NH like so. And this time, instead of taking off the OH, I take off the Cl like that. And so what I'm left with now is this carbon with the C-double bond O and this nitrogen forming a bond together. There we go. And it forms a very similar structure that we saw before. And so here, around my functional group middle, I've got the same kind of amide link. There we go. And then I've got my carbons just here, that's those two. And my nitrogen at the end, which I'm going to show the repeating unit of straight away. Pull that off. And so I'm left now with that on this side. And then going down this side of the molecule, I've got the carbon just here, that's that one. And I can put my H's on that. And then when I get to this carbon at the end, I'm going to take off another Cl, just like I took the OH off the previous one. So there it goes. I've got my C-double bond O on that edge. Bond sticking out, my arm sticking out just there. Don't forget these H's, quick as I can. There we go. And I would have N of that repeating over and over. But as you can see, what happened there in the middle was a little bit different. We ended up plucking off the Cl and the H. And so all that happens this time, a little bit different, is I make an HCl, which I can't seem to clip together. This is not the difficult bit. There we go. HCl. So the HCl came from when this bond was formed in between the two. And it was formed from the Cl just here and one of the H's from there. And this little HCl, sorry, just pops out over here. And so what I need to show is plus HCl instead of H2O this time. And what I put in the brackets is the same as before, 2N minus 1. So I got one from the middle, making the amide link in there. And I also got one from either end. So there were technically two, but I don't need to show them both. Move. Hopefully that gives you some clarity then of how we can make a polyamide and how those look. Also using an amino acid for that. There is another video for amide bond formation if you want to have a look at that straight after this one. And don't forget to check out the polyester one as well. If you click the little I, which is up here on the video, you can get taken to loads of different things, including our playlist. And you can also take part in the occasional survey I'll chuck in there. So hopefully there is one. Otherwise, I'll leave you to the rest of all of our work. Happy revising.